Hey, what's going on, guys? In this video we are going to see how to find unknown voltages using nodal analysis by inspection method. Now in order to do this method we have to follow all these 6 steps. The first step is find a reference node with known voltage. So for this part what we do is we connect the bottom to the ground. In that way the bottom part is going to be just 0 voltage, right? So it's going to be 0 voltage, and the next step is assign voltage to the other nodes. Other than these bottom parts we have 3 other nodes, this node and this node and this node. So let's name it as V1, V2 and V3. And the next step is assign conductance to resistors. So conductance is, first of all we have no conductance, that is G is equal to 1 over R. This is the equation for conductance. Now let's look at the resistance. First we have this resistance 4 ohm, so the conductance is going to be 1 over 4, and here we have 6 ohm, so the conductance is going to be 1 over 6, and here we have 8 ohm, so the conductance is going to be 1 over 8, and here we have 6 ohms, so the conductance is going to be 1 over 6, 1 over 3 right here, and 1 over 5, right? Now the next step is assign, we follow this one. The next one is find the elements of the conductance matrix. So conductance matrix is, what we do is we take G11, let's get rid of this one, right? G11. So what does this mean is, like, we look at the voltage 1 and see what are the conductance that's connected with this V1 and we add them together. And if you notice we have 1 over 4 connected, so we put 1 over 4, and also we have 3 ohm connected with this one, so we put 1 over 3, and also this 6 ohm also connected, so we put 1 over 6. And here the common denominator is going to be 4 times 3, 12 times 6, 12 times 5, 60, 72. Okay, or 12 will work. 12 is good, right? 12 is good for common denominator, and if you take 12 as a common denominator, this is going to be just 3, this is going to be 4, this is going to be 2. Now 4 plus 3 is going to be 7, 7 plus 2 9, so 9 over 12, that's going to be equivalent to 3 over 4. So this is our first matrix, conductance matrix. The second one is going to be G22. Since we have 3 voltages, it's going to go like G11, G22, G33. Now G22 is going to be the conductance that's connected with this voltage 2. This 3 ohm is connected, this 5 ohm is connected, this 6 ohm. So we are going to have 1 over 3 plus 1 over 5 plus 1 over 6. And the common denominator for this one is going to be 5 times 6 is going to be 6 times 30, 30 times 3, 90, right? Oh, 30 is good. 30 can be common denominators, 30. And if you take 30 as our common denominator, this is going to be 10, this is going to be 6, and this one is going to be 5. 10 plus 6 is going to be 16 plus 5, that's going to be 21, right? So this is going to be 21 over 30, and if we divide by 3, this is going to be 7 over 10. Let's look at the next part, G33. We have to look at the conductance that's connected with voltage 3. 8 ohm is connected, 5 ohm is connected, also this 6 ohm is also connected. So this is going to be 1 over 6 plus 1 over 5 plus 1 over 8. Let's look at the common denominator. 8 times 5, 40. 40 times 3, 120. So 120 can be common denominator right here. And if I take 120 common denominator, this is going to be 20. And this is going to be 24. And this is going to be 15. And if you add them together, you should get 59 over 120. Now we have all these 3 things. Now let's look at the next part. So the conductance matrix between each 2 nodes, like wherever we have voltages, we are going to look at the conductance in between. since we have V1 V2, the conductance, we have to look at the conductance between this V1 V2. That's going to be G12, also G21, and conductance between that is 3, 1 over 3. So this is going to be 1 over 3, and here we have to do one more step. We have to put a negative sign in front, and then we have 2 and 3. So we have to put G23 and G32, and the conductance in between is going to be 1 over 5, and also we have to put a negative, so this is going to be 1 over 5. And the third one is going to be G13, because we have voltage 1 3, there's a conductance in between these two, that is 6 ohm. I mean 1 over 6 ohm is resistance, and 1 over 6 is conductance. So this is going to be G13 and G31, and that's going to be equivalent to minus 1 over 6. Now we have all the information. Now we have to put all of them in matrix form. Okay, so this values 1 1 2 2 3 3, all of them refers the row and columns. 1 means first row first column, second row second column, third row third column. So this is going to be a diagonal, like in 3 by 3 matrix. These three values are going to be diagonal, and the first one we know that 3 by 4, G11 is 3 by 4, we put it in first row first column, and 7 by 10 is in second row second column, and 59 over 120 is in third row third column. So this is going to be 59 over 120. And the other thing, this one, the conductance in between, here we have 1 2, the conductance in between V1 V2 was 1 2 2 1. So this is first row second column, so that's going to be minus 1 over 2 right here. First row second column is this one, right? So this is going to be minus 1 over 3, and then second row first column is going to be right here, minus 1 over 3, and then we have 2 3, second row third column, so it's going to be here, minus 1 over 5, and then third row second column is going to be here, minus 1 over 5, and the last one is first row third column, that's minus 1 over 6, and third row first column minus 1 over 6. So now we have the matrix. All we have to do is do the Cramer's rule, but before we do that we have to know one more thing. So we are going to have V1 V2 V3, and after the equation sign, now we have to look at the current sources entering each voltages. So we first of all we have to look at the V1 and see what are the current sources entering this one. And if you notice, here we have 6 amperes entering. Also this 4 amperes going out of this. So 6 minus 4, that's going to be 2. And let's look at the V2. V2, we don't have anything entering or anything exiting from this one, so that's going to be 0. And V3, 4 amperes entering, so that's going to be 4, and we don't have anything exiting or any other thing, so that's going to be just 4. Now we have this information. Now we have to do the Cramer's rule. Cramer's rule, if you remember, that's going to be, first we have to find the determinant of this one, this original matrix. So let's refer as determinant, and then after that, after you find the determinant, also you have to swap this one with each of them, right? If you want it to be clear, I put the matrix right here for each of them. I get rid of this part. Okay, so the first matrix is going to be the original determinant. That's going to be 3 over 4, minus 1 over 3, minus 1 over 6, and then minus 1 over 3, 7 over 10, minus 1 over 5, and then we have minus 1 over 6, minus 1 over 5, 59 over 120. And first we have to find this determinant, and then first determinant, to find the voltage 1, we have to swap this one with the first column. So that's going to look like this, like 204, and after that other value is going to remain the same, minus 1 over 3, 7 over 10, minus 1 over 5, and the third column is going to be minus 1 over 6, minus 1 over 5, 59 over 120. So this is going to be our first one, and the second one, you swap this value with the second column and first column remains the same. So this is going to be just 3 over 4, minus 1 over 3, minus 1 over 6. The second column is going to be 204, and then the third column is going to be minus 1 over 6, minus 1 over 5, 59 over 120, and you find the determinant. So you should do the same thing for the third one. You swap this one with third column and find the determinant. And final equation is going to be, to find V1, what we do is we put the determinant on top and divide by the original matrix determinant. And V2 also same thing, 2 over determinant, and V3 is also same thing, like 3 over determinant. And if you calculate this one, the first one is going to be, I have the values. If you calculate V1, you should get 10.1772, and if you calculate V2, you should get 9.22895, and if you calculate V3, you should get 15.3395. And that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.